Hello and welcome to the continuation of the suddenly interrupted 1912. Kalle, on the invocation of Kalle, we will give it another number, 1913. And we continue directly where we left off, page 62, subtitle Concluding Remarks is actually the next page there, Kalle. No, it is actually the roof. No, it is concluding remarks. Or am I wrong? No, I'm wrong. The rule following argument it is. Sorry. Particularly well-known and notoriously difficult, satisfactory to rebut, is Wittgenstein's rule following argument, to the effect that each time we apply a rule, there is in some sense an indeterminacy as to what applying the rule amounts to on this occasion. An example taken for consideration is where an individual appears to be successively adding 2, but then in their determinations they suddenly diverge from what an observer expects. It is relevant to say that a given mathematical series, more than one rule may generate its early members, but then give different values at a later point. As presented, Wittgenstein's argument is entirely general, so any sense of context tends to be lost. Is it helpful, one may wonder, to consider a young child learning to count, or the limited arithmetic of a tribal society, or present-day higher mathematics? In fact, further to the discussion of the solution of quartic equations above, one can even construct an imaginary example from higher mathematics, which may be illustrative. Suppose, as a 21st century mathematician, one is overlooking the work of a 16th century mathematician who is seemingly recording the number of roots of a series of quartic equations, making due allowance for repeated roots. He records an extended series of 4s, and we may be led to expect this to continue, but then all of a sudden he records 2. Oh dear. Where an individual says there are following a rule which may or may not identify explicitly, or where they appear to be following a rule and they then act in an unexpected way or may seek to go behind it by asking them to explain their choice or decision, or by investigating it indirectly. In the example just given, it might thereby be quickly revealed that only real roots are being counted. Again, supposing the context is of a young child learning to count, one might have to recourse to the use of counting beads or Cuisenaire rods. Importantly, there is nothing in Wittgenstein's example that prevents an individual subsequently being led to an alternative choice or the genuinely held judgment that they had previously made a mistake, but arguably there is also nothing that compels them to do so either. Again, while taking Wittgenstein's point regarding the unbridgeable gulf between rule and application, or law and special case, little or nothing follows from it regarding the extent to which or context within which unresolvable is issues of that type may be expected to be encountered in practice. In connection with arithmetic or any part of mathematics, is what is crucial is not that we are capable of coming to differing judgments or assessments, but the recognition that there is an objectively given criterion as to the correctness of the count, the sum or the relevant calculus.
Some.
Calculus, indeed. Significantly, the use of such objective criteria enters into the design of the aids we employ as calculators and computers, which therefore serve to discipline our behavior. The nature of Wittgenstein's unbridgeable gulf could be such that the majority of a population fails to recognize a standard of correctness and or their own regular departure from it. That this is not the case, and that we recognize the possibility of our own mistakes and struggle to correct them, lies at the heart of the institution of mathematics within society. Mathematical rules can only be said to function where they are sustained within common linguistic practice. Happily, the position in society today. Hooray!
Happily the position in society today.
Indeed. Concluding remarks. In a strikingly impressive way, the Tractatus lays bare the essentials in terms of abstraction and generality. Within the account, Wittgenstein characterizes and situates mathematical propositions or pseudo-propositions, while departing from Russell's and Frege's versions of logicism. However, given that important work's character and aspirations, one is entitled to ask whether in its own gnomic terms it does justice to mathematics. Doubts in this respect center on narrowness in its characterization of the subject matter, given a focus on the mathematical equation. The reader is rather left wondering how Wittgenstein would situate not just the inequalities cited by Ramsey, but a variety of other propositions. An extension of Wittgenstein's analysis to incorporate the wider structure of mathematical reasoning might well lead one back towards a logicist account. With the help of examples, the relation between the meaning of an arithmetical generalization and its inductive proof has been explored, but one is unable to conclude that the former consists of the latter. To be fair to Wittgenstein, it may be that his doctrine is to be interpreted narrowly as being solely concerned with mathematical induction and does not even extend to include the fundamental theorem of algebra considered here, but there is considerable interest in examining the relation more generally within mathematics. In marked contrast in relevant respects to Fermat's last theorem is the fundamental theorem of calculus. In that case, extended study is needed to gain understanding of the context, preliminaries, and formulation of the theorem. But the increment of understanding then needed to grasp the proof is relatively slight, meaning of general proposition and of its proof are evidently close. Close. The attempt is made here to meet directly some of Wittgenstein's objections to the mathematical treatment of infinity and irrational numbers. Infinite processes play a central role in the subject, particularly in differential and integral calculus. Its crowning glory is agreed among mathematicians that the analytical work of the 19th century by Weierstrass and others provides a perfectly sound basis. Yet it is one of the essence that only a finite number of steps are taken in that analytic reasoning. As Wittgenstein reminds us, let us not forget, mathematicians' discussions on the infinite are clearly finite discussions. By which I mean they come to an end. To challenge their approach would simply require a challenge to one or more of a finite number of steps, but no such challenge is evidently forthcoming. There is thus a sense in which the infinite is satisfactorily addressed by the finite, yet emphatically this need not involve adherence to a doctrine of finitism. Oh no!
Finities.
Wittgenstein's comments on the place of transfinite numbers within mathematics are informed by considerations similar to those he judges to apply to more elementarily seeming extensions of the number concept. For instance, that from the natural numbers to the integers. His view is that we are presented with a further extension of the family of systems subsumed under the concept of number. There's an important difference to note, however. The extension from natural numbers through to the real number continuum are all to do with extending the use of rational operations while preserving the rules. Any supposed extension to transfinite numbers is, however, of an entirely different order, partly because there is no preservation of rational operations and the associated rules. No, not at all. Hence, a challenge to the claim that the introduction of transfinite numbers extends the domain of the natural or the real number systems is well founded. Wittgenstein surely rightly values absolute clarity and also, in a not unfamiliar way, sees merit in the potentially creative perspective of the young child. Philosophical clarity will have the same effect on the growth of mathematics as sunlight has on the growth of potato shoots. A mathematician is bound to be horrified by my mathematical comments, since he has always been trained to avoid indulging in thoughts and doubts of the kind I develop. I trot out all the problems that a child learning arithmetic, etc., finds difficult. The problems that education represses without solving, I say to those repressed doubts, you are correct. Go on asking. Demand clarification.
Clarification. Clarification.
And I think we end there for a concluding remarks and the whole paper there. I will go back for some comments. I have to sit here. I do agree with this last one. But let's see here. Well, it's rather long read, so I'll be making a summary of both 1912 and 1913, since we were abruptly interrupted. I go to page 57, if you may. And on the top of 57, the third paragraph, third line. So Wittgenstein's argument, it starts with, as indicated earlier, however, it is quite inappropriate to speak as though pi fills a gap, because a gap is a measurable interval. What he mentions here is the invention of space, or the idea that numbers parallel or represent space, or they occupy space, some sort of space, fills gaps in an endless number series with a finite ending, as we mentioned earlier. That poor person counting to the last decimal of pi. Terrible destiny. That creates an obfuscation, an unclarity of great width. You get a parallel world, and the parallelity is an illusion. The last sentence Yet the very fact that there are formula giving its value to any required number in decimal places, it identifies and secures its unique place within the decimal expansions of irrational numbers. Incredibly pertinent. We combine that with the next page, with a paragraph. It's about the fourth paragraph, beginning with importantly. And just before here, Cantor has made something absurdum. He's using space, and he says that two number lines, the natural numbers and the even numbers, can be placed next to each other on a diagonal. And that is, of course, an impossibility if there is no space for the numbers to be put in, or that the diagonal process is a sort of nonsense. That never happened and could not happen, as you can see in the following sentence. Importantly, Wittgenstein tells us philosophy may in no way interfere with the actual use of language. It can, in the end, only describe it. It leaves everything as it is. And we see the problem establishing more in Cantor for the last sentence on that page, or penultimate, I think it is. Thus, such as Wittgenstein, who object to the type of non-constructive reasoning employed by Cantor, focus inter alia on its character as an essentially indirect proof. It's not a proper proof. As above, the form of an indirect proof follows this pattern to establish the truth of a statement then one makes the provisional assumption that its contrary is true. And this is an incredibly dangerous sort of reasoning. Reasoning by contradiction. You assume something, you prove it to be false, and therefore you assume the contradiction to that. That is the logical principle of the excluded middle. The absurdity of a contrary statement is taken to establish the truth of the original statement. Used by atheism a lot. I see that somebody could say, I can see that the priests and the bishops and the church are doing bad things. Therefore, the contrary must true. There is no God. There are no religious people. There are no spirits. There is no free will, and so on and so on. The law of the excluded middle is revealed by Wittgenstein in its essence, how it really works. And it's more complex. And do not confuse those instances, those places where it does have a reason to exist, but not here. We can go further to page 60. And on the third paragraph, and 6 lines down, however, according to Wittgenstein, what is happening is that an empirical proposition arising out of experience is converted into a proposition which no experience would lead us to give up. We have made mathematics by doing the excluded middle and other things immune to reality, immune to what is called empirical or experiential disproval or epistemology. And that is, of course, very bad. It's not fruitful for mathematics at all. It has lost its criterions when there is no longer a connection to use. Användning, as we say it in Swedish, can't help to see the beauty in that. It is done mathematics by hand, by numbers, by symbols. It's a piece of paper. In the end, a circle is a scribble, I was mentioned before, it's a scribble on the paper. Whereas the transcendental circle is perfect. There is no such. It's not an approximation. Yes, a perfect circle can be useful, but it doesn't really exist. As we know from Terry Marx-Tarlow, reality is fractal. Perfect line cannot be drawn. And I'd say Wittgenstein is showing it cannot even be imagined because there is no criterion for it. It is in the private language box. It doesn't exist. It's a piece of nonsense. From where pi stems, and from where the square, the perfect square, we have the square root of 2. I think you get the drift now. Illegal parallels make for these irrational numbers. These most difficult real numbers. If we go to the next paragraph, we have yet another one. in the latter case, I jump into the sentence, sorry there, but not in the former, there is a discernible tendency of linguistic practice to assert that something is true of ideal elements such as geometrical lines and circle. It is implied that it may not precisely be the case, for the instance, for lines or circles drawn on paper. That's the absurdity. That's really dangerous. Because then we lose our foothold on the ground. And we skip to pure geometry, the last sentence. Pure geometry proceeds against the background of continued understanding that there is a gulf, listen now, between the world of experience and the abstracted model, even given the illumination that each provides of the other. Do you get it? Now you have it. Already the Pythagoreans did that mistake, assuming that they are perfect squares, and once the square root was shown to be a real number, that heretic got killed. That goes to show how important these things are for our Westerners. And they have become, the mistake or the misuse have become more gruesome as the years passed. Wittgenstein, which is the next sentence here, page 61. Wittgenstein was fascinated by proofs of impossibility. For instance, those directed at problems in ancient Greek geometry concerning the straight-edged and compass trisection of an angle, squaring of the circle, and construction of a regular heptagon. It's a seven-sider, if I don't misremember. Hepta. We can use the perfect things, but they are not more real than the drawn circle. The drawn circle is in reality. The other one is not. Goes for a big difference. But hope is there on page 63. The second paragraph, last sentence, indeed. At the very end of the second paragraph, see here, the second, if you need to go up a bit. But quite a bit more, second paragraph. Beginning with the attempt is made. There, at the end of that paragraph, the second paragraph, at the end of it, you make a There is thus a sense in which the infinite is satisfactorily addressed by the finite, yet emphatically, these need not involve adherence to doctrine of finitism. that is in itself the hope we have. We need to go back down a bit there. Yeah. Oops, jumping the whole thing. This, we do not have to go to finitism. No, it's page 63, second paragraph. No, finitism. You are a bit off. Yes, you found it. Very good. So we do not have to strand infinitism. And finitism is, I think, the culprit of downside of mathematics today, where it loses its fruitfulness. And later, as described by Wittgenstein, philosophical clarity will have the same effect on the growth of mathematics as sunlight has on the growth of potato shoots. It will make mathematics grow once more and becoming something of importance, not as today as a lurky, dark and platonic area, but actually doing things, being active in the world, not going beyond. And of course, as it says, we can have infinite, but we do not have to have finitism. The idea that the whole number series can be ended somewhere. There's no need for that. We do not have to have a universe with a start and an end either. Or we do not have to have eternal physical laws to have physics as proven by quantum mechanics. It liberates us from that and makes mathematics and physics and human nature to grow. Poor Kalle, now you can come in finally. Thank you very much for your patience.
We need to return to the previous lecture. Give me patience. So I think that there is a contradiction here. So we have the Wittgenstein is against doctrine of finitism, as you said.
Yes.
That is
He's not against
that
it,
implies
but
that everything has a start and end.
yeah.
As you said, with the example of a universe, that everything follows rational rules with a starting point and end with a big bang, and then while in quantum physics, it doesn't work in that circular, in that linear fashion.
No, exactly. With
So okay, so far so good, so far.
Yeah.
Because in quantum physics, it's like you, so to say, create. It is a continuous creation, you could say.
Yeah. I think that's a very
Yes,
good
it's continuous
saying.
creation. But let me see. We had this last time. Where did we? Let me see. The last time in 1920. Where we did, 1920. Where did we have it with the three dots? Do you remember the example with the three? Ah, yes. So the square root.
No, yeah, sure. Yeah.
Yes. It's on page 56. Page 56. Let me see where I am now.
56, you said, okay.
Yes, page 56. This is. Oh no, I went too far. Page 56. Page 56. So it's this page 56. Thank you for your patience. Yes, here, indeed. So you had in this example, like, so you can indicate third when you say this is a third of the cake, for instance, or whatever. And then you indicate this for numbers, it's 0.333. That is, this is example of infinitism. Do we agree on that? But the point is that Wittgenstein was against this the three dots. He didn't agree with these three dots because it removes responsibility from you. Or
Yeah, yeah. Real
is there
number
not a
continuum.
contradiction?
Real number continuum. Think at you can compare it to space, where all the decimals are living their own life, and we do
Mm-hmm.
not have to be there. And it's an endless number series that ends with a big crunch or somewhere, but we will never get there. And without an observer, without anyone, they just continue forever and ever and ever.
So you could say that there is something unreal with this 03333, while
Yeah,
you could say yes, there is
yeah.
something unreal with this, while
It's
while
okay as long as you don't put numbers that you don't put there, so to speak. If you say
so you
there
could
are
say
numbers, yeah.
so you could okay, I think this clarifies the thing. So you in everyday life you can say this is third of a cake, for instance. That's
Yeah,
something real. That is something real, tangible.
yes.
While if you say that 0.0333333, that is something irreal.
If you
Uh,
go to say that there are numbers beyond what I say or put on a
mm,
piece of paper or having a computer, then it becomes finitism and problematic.
mhm. So you could say that okay, saying third, that is something real. That's also you could say perhaps also say that is example. Mm, um, it's kind of example of infinitism. No, I don't know. This is I don't think perhaps it applies here. Um, while no, I think that the concept of finitism or infinities can also be misleading in this case because 0333 that would be an example of infinitism actually, but infinitism in the negative sense. Do you
Yes.
understand?
Yes, if
Because
it
it.
goes beyond what you actually do. But as you say,
Mm-hmm,
you can cut the cake in three parts.
mm,
And then there will be a Platonist who say, oh, look at my piece of cake. That will continue endlessly until its finite end, somewhere beyond what I can do.
mm-hmm. So let me resume. So there is infinitism that is both good, and there's infinitism that is bad. So the bad
Hmm.
infinitism is that you think that this is some way real. You say 0333, that is something real. But this infinitism is good because it implies that it's continuous creation, so to say.
Hmm. Yeah, yeah. For every new three you put in, you did put it there. You created. It's there. But before you
Mm-hmm.
put it there, and to say that something you never put there exists, that's problematic in an
Mm-hmm.
obvious sense.
Mm-hmm.
It's like to have a cake that doesn't exist. It's very close actually.
Mm. And so let's say this also reminds me of the case with what the remarks Tallow had, that you can say that in America, the average family consists of 2.5 children, two and a
Yeah,
half
yeah, yeah,
children. That is
yeah.
something
Yes,
unreal.
very good, Callum. Funny.
Um,
And also, you had good help with the perfect circle. Who doesn't believe in the perfect circle? It's not a
mm,
circle, it's not perfect. It simply doesn't exist.
mm, 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 mm.
Piece of paper
Uh,
is fractal. You know that. Everything's fractal.
yes, absolutely, absolutely. And I think we have. Let me jump now to page 61. Page 61. Let's go to page 61. It's 5 pages down. 61. Let me see. One more page. 61. Yes, here. I think the point of this whole paper is actually expressed here on page 61.
Yeah, it is. Very good. You get it, Kalle. Very good. I hope you listeners and viewers get it as well. It's not that
So
difficult.
let me say it. It is that understanding which eventually opens the way to the substantive question as to whether Euclidean or non-Euclidean geometry is to be preferred as a description of the geometry of the physical world. So the answer is, of course, so to say,
Yeah.
non-Euclidean geometry, because it's the nature of, there are no perfect circles in the nature, for instance, so it's a fractal geometry. I think the downside with the Renaissance was, or the Italian Renaissance, is that you had these ideals, pathologic ideals, like with Giotto. Giotto was famous for being
Yeah.
able with his hand write the perfect circle. That is impressive on one side, but it's also frightening on the other side, because it implies that it's something. So it's still doing, but still frightening. That should be the ideal. There's a double-sided thing, of course.
It's double-sided. It can be very useful in some instances, but if you take it too far, which they do, and then you leave your foundation, and it's absolving Platonic ideas from the inside. It doesn't say that Platonic ideas are wrong. It says that you can't understand what they mean. They don't really mean anything, which is much better. Which is much better. No longer you have to go around saying I don't like them. You can just leave them aside and never be bothered by them anymore.
Hans, can you explain in simple words what is meant by proofs of impossibility? That there are.
It's very common. It's very, very common. So they create a proof by something that's impossible. To say if I can fly, that's an impossibility. Then I can walk. It doesn't follow really. And the Greeks were very fascinated by that as well, but in the wrong way.
Let me put it here.
It's the law of introduction, the law of the excluded middle, with other words.
Ah, yes, okay.
I think that's the simplest way to put it. It's unlawful. You cannot use it that way.
While in integration you don't have proofs of impossibility. So the exclude middle is an example of proof of impossibility.
Yeah, what do you say, Kalle? Should we end there, maybe?
Yes, let's end there.
So we've been looking at the Platonic forms. We've been looking at endlessly varied numbers, and we've seen how we can save ourselves from ideas of Platonic ideas going too further into that. And we also see that there are no perfect shapes, but that actually even more, they don't make sense. They are senseless rather than wrong, which is quite a difference. Kalle Lunda, thank you for your excellent patience and your nice impositions. Thank you everyone for listening in. Have a very wonderful day, morning, or afternoon, wherever you are. Bye bye for now.